Hi, in this video, I'm going to talk about the IPv6 link local address. All right, so that's this address right here, one of the unicast addresses. Okay, a link local address has the range of FE80 to FEBF. That's because it has those first 10 bits, as you can see there in bold. Link local address. So let's talk about what this means. Link means a network segment. Okay, you separated by a router, segmented by a router. Link local means local to that link, to that specific part of the network. So it's used to communicate with devices on the link, just on that network, not to be routed off the link. Okay? So it's just for communicating with devices on the link. Only has to be unique on that link. Okay, because the routers do not forward any packets with a source or destination link local address. Okay. It's not included in the IPv6 routing table of the router because it's not going to route it. And a device must have an IPv6 link local address to be IPv6 enabled. It doesn't have to have a global unicast address, but it must have a link local address. Let me just talk briefly about one of the many benefits of a link local address. The cool thing is when we'll see in a moment that when this device, let's say, boots up, it will give itself automatically a link local address. We're going to see how this is done in a little bit. But the beauty of this is that all of a sudden it can communicate using its link local IPv6 device with any other device on the network, including the local router. And we're going to see that's important because it can get its global unicast address using information from the router. Called a router advertisement, but we'll get there a little later. Okay, let's go on to the next slide here. Okay, so how are link local addresses created? Okay, so I mentioned that they can be created and most commonly are automatically by the device. So it's usually FE80, okay, for the first 10 bits, okay, then double colon, and then the interface ID. The interface ID can be done automatically using something called EUI64, where it uses a MAC address. We'll talk about that in a later video, but just a little bit more in a moment, or by a random number, or can be statically configured. Okay, so we'll see this here more in a moment here with a Windows device, but devices typically will give themselves their own IPv6 link local address, beginning with FE80 and then a double colon. So then we have just the interface ID it needs to come up with. I mentioned it can get this interface ID one of two ways automatically. EUI64. We'll talk about this more in another video, but this is where it actually uses the Ethernet MAC address to create this 64-bit interface ID. Or can just come up with a random 64-bit value. And that's what most operating systems are moving towards now. But they can also be statically configured. This really don't need to do except on routers. Okay, and we'll talk more about that later when I get into routing protocols for IPv6 in other videos. All right. So, thinking, do I run IPv6 on my device? You are. Whether you're running you have a Windows PC, Linux device, or a Mac OS device, you're already running IPv6, which means the network is running IPv6. Whether or not your router is running it is a different story. A lot of home networks now, like my network, I'm a Comcast customer, they run IPv6 for all their residential customers. So most people don't even realize that when they're going to Amazon, Netflix, Google, LinkedIn, Facebook, that's all happening over IPv6. All right, so notice though we have an IPv6 link local address. So that's what I mean. When a device boots up, it already has an IPv6 device. I'm sorry, device, IPv6 address that it's given itself. In this case, it was used, the interface ID was random, and I'll talk more about that a little later. Okay, so, but the important thing is even if you're not running, if you don't, as a network administrator, if you haven't deployed IPv6 on your network, you need to understand and secure it, because guess what? Your clients are running IPv6. If we take a quick look at this link local IPv6 address here, we can see that it is FE80, the double colon, and here's the 64-bit interface ID. And Windows uses a random value here for these 64 bits. All right. Okay, so how is IPv6 link local addresses used? And this is just a quick overview. Okay, so I mentioned that IPv6 addresses will be used by the device when it boots up to talk to a router so it can get things like a global unicast address and its default gateway information and other information. Okay. Routers use link local addresses to communicate with devices on its own network. These are router solicitation and router advertisement messages. You'll usually see that the clients, the devices on the network, for their IPv6 default gateway address, it's the link local address of the router, because it only has to be an address that is accessible on that link. Okay, routing protocols, IPv6 routing protocols, routers exchange routing information using their link local addresses. All right, so this is just a short introduction into what a link local address is. You'll see how it's used in more detail in later videos.